So what does replacement notation and mapping notation look like when we're doing a reflection? Well, first things first, remember we have to start off with this wonderful thing we call our function. Yes, y equals to f of x. Now, if you remember correctly, a vertical one and a horizontal one just means putting negatives in. But where the negatives go is what's really, really important. For example, look at this guy. Aha! The negative goes inside. It's next to the x. That tells me right away this has got to be a horizontal. This is a horizontal for sure because it is emphasized by putting it next to the x. So remember, if you're going horizontal, right, you're going this way, what axis do you cross? You cross the y-axis, of course. So this is a horizontal reflection in the y-axis. So that's the line where x equals to 0. We call it a horizontal reflection. Boy, that's not tough. Now, look at the other mapping notation. You're going to take the negative y and you're going to put it in there and replace it to give you the new function that looks like that with the negative y in front of it. But don't forget, we can always go back to our math 20 idea where we can take that negative and just pop it over to the other side by multiplying both sides by -1. This gives us a negative f of x, which looks an awful lot like, remember, y equals to negative x plus something, let's say x plus 2 squared, which that negative up front means it's a vertical reflection. Don't forget, a vertical reflection goes this way, right? Vertical goes this way across the x-axis. And that's one of the reasons why you have across the x-axis here. Let's look at the mapping notation now. This is what our equation becomes. Remember? So maybe I'll just do a real quick sum up. That's a good idea. Hey, I'm glad I thought of that. Look, if you're doing a horizontal, okay, the x, right, gets mapped to, or gets replaced to, sorry, not mapped, replaced to a negative x. If you're doing a vertical, okay, the y gets replaced by negative y. So basically what you have is you get a negative y equals to f of negative x. That shows both the horizontal and vertical flips. Right? Got it. Look at mapping notation. Here's where you have to kind of think again. If you think about it, it says in something like this. Bada boom, right? Remember, you're flipping this way, up and down. So what coordinate does it affect when you're going up and down? The y coordinate, of course. So here's what the mapping notation will say. You take every point, every original point, and you just flip the y coordinate. That's all you got to do is flip the y coordinate. Make it the opposite of what it is. So if you've got a coordinate here that's like 2, -3, perfect. Make this 2, +3. That's easy enough to do. That's what mapping notation says. Mapping notation takes every point and tells you how it changes. So look at this one. If you're doing this next one, okay, bada boom, look what you're doing. Emphasis on the x, which means, guess what? Emphasis on the x. This, of course, is a horizontal flip. Think about it. When you're going horizontally, you're changing the x coordinates. Aha! Remember from the last podcast we talked a bit about invariant points? Da, 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 da. Here's the big notes on the invariant points. It says an invariant point is where a point maps onto itself. In other words, the point remains unchanged after the transformation is applied to it. Okay? So any point that lies on the line of reflection is considered an invariant point. For example, when we're doing graphs just on the last podcast, remember how we flipped? We had one that looked like this, and then we flipped it over to this side. Aha, look, there's the x. There are the x's. They flipped that way, the x's don't change. Ta-da! That's how it works. Okay? So here's an important note. A reflection in the y-axis means that the y-intercept is invariant. Aha! A reflection in the x-axis means that the x-intercept is invariant. So let's play. Let's go take a look at some examples now and see what we can do. Here's a great example, and we're just going to do example 2 in this podcast. We'll leave example 3 for the next podcast. Take a look at this. It's just a point, -3, 4 lies on the graph of this function. State the coordinates of the image under the following transformations. Well, think about this. Isn't this first transformation just a -y equals to f of x using Math 30 notation? Do you not see right here the emphasis on the y? So look, we're going to do a quick mapping. -3, 4 is going to be mapped. You're going to change the y coordinate to -3, -4. Oh, that was so difficult. I need a coffee after that one. Huh. Okay, look at this one. The negative is on the inside. So that's emphasis with the x. So let's do a mapping here again, shall we? Here we go. -3, 4 is going to be mapped to 3, 4. Yay! Why? Because the negative is with the x coordinates. Okay, finally, the last one. Notice how you've got this coordinate, which of course will bring it over to the y side because we like our Math 30 style of notation. Yay! All right, so with that in mind, what we're going to do is we're going to take that original point, which was -3, 4, and we're now going to map it, and this tells us change the y and change the x. So this becomes an x value becomes 3, and the y value becomes -4. Whoops, there we go, and it's done. That's how you do the mappings and the replacements. Whew, I'm tired. That's a good one. I like this one.